Hello, my name is Samu Kukkonen. I am delighted to give you an introduction to Normet's brand new electrodynamic driveline technology. We at Normet strive to innovate for safety, performance and sustainability. With the electrodynamic driveline technology, we can improve all of these. Let's have a look how it works. Normet has a long experience in developing fully electric battery-operated machinery, the Normet Smart Drive, but also engine-powered machinery. With the electrodynamic driveline, we have combined both. By augmenting the latest low-emission Stage 5 engine with fully electric driveline, we have achieved a leap in productivity while improving safety and lowering CO2 emissions. This is the electrodynamic driveline. It is the very best of both worlds. Take a look at this electrodynamic application, the Normet XL1100 agitator electrodynamic, which can fit 10.5 cubic meters of concrete, and compare it to the LF600 agitator, which can fit 5.6 cubic meters of concrete. Both machines are roughly the same height and as agile. This means that both machines fit the same tunnel envelope, but only the XL1100 can transport over 85% more concrete per trip and hence is much more productive. This was achieved with Normet electrodynamic driveline technology. Let's take a look inside the XL1100 electrodynamic driveline. First, we have installed robust externally oil-cooled axles to the machine. Then we have connected permanent magnet motors in direct drive configuration to the axles, providing instant torque and high efficiency. As you can see here, there are no gearboxes and hence no gear changes. Next, the power plant. A low-emission Stage 5 engine coupled with a generator is fed to the machine. This generates electricity for the electric motors at the axles. What is unique in this configuration is that the engine RPM is completely decoupled from the machine speed, meaning that we have infinitely variable transmission ratio, which optimizes fuel consumption and performance. Next, you can see the motor drives and the cabling. This cabling is the key because we can freely route the power to the rear axle without a need for a drive shaft. It enabled us to utilize the space where the shaft used to be and to increase the payload capacity by over 85% while keeping the machine height similar to conventional machines. The increased payload capacity means that the machine emits less CO2 and consumes less fuel because fewer round trips are needed to transport the same amount of concrete. The electrodynamic driveline enabled us to provide innovative retardation systems. In addition to the powerful engine braking, the electrodynamic has a braking resistor that is used as an electrical load heating water when extra retardation capacity is needed. The control of both the engine brake and brake resistor is fully automatic. Let's see how it drives. First, we will do acceleration and deceleration on flat surface. When the operator presses the accelerator pedal, the machine will accelerate readily and smoothly without gear changes. In this situation, the engine RPM will increase to accelerate the machine promptly. After acceleration, when driving at steady speed, the engine RPM will automatically come down to optimize fuel consumption. The engine will run quietly at low RPM even when driving at full speed. Next, we want to deaccelerate, and we do this simply by lifting the accelerator pedal. The machine will smoothly and controllably slow down all the way to zero. The engine will absorb the braking power, reducing axle brake wear. When the machine stops, axle brakes are applied automatically. This hill hold feature will hold the machine in place even in a steep incline. Next we will drive the decline. This is done simply by defining a suitable speed with the accelerator pedal. This means that the machine can be driven with one pedal only, even in steep declines. The electrodynamic driveline will hold the speed steady by regulating retardation systems automatically. It is the engine that will absorb braking power, further assisted by the brake resistor. All of these features make the electrodynamic driveline very easy and safe to drive. Next, we will unload the concrete, and this we can do with zero local emissions by connecting the machine to the power grid. This increases operator comfort and saves fuel. Now that we have unloaded the concrete, it is time to drive back to the surface. During uphill driving, the engine will run at optimum RPM for maximum power and least fuel consumption. If one wants to stop, it can be done easily by lifting the accelerator pedal. Machine will stop and apply axle brakes automatically for hill hold. When the accelerator pedal is pressed again, the axle brakes will be released and the machine will steadily accelerate forward. Overall, as you saw, the machine is very easy to drive. Now the operator can pay more attention to surroundings instead of machine controls. This decreases likelihood of accidents. At Normet, we have verified the safety of the electrodynamic driveline by careful analysis and testing in real mining environments. We have pushed the driveline to its limits through comprehensive testing by multiple different people with different viewpoints. Together with Smart Drive, the electrodynamic is one of the most comprehensively tested technologies Normet has ever made. Thank you for your time.